Welcome to Calc-Path Geometry, lesson 1.5 from the first algebra unit, unit 1. We're looking at graphing two variable equations. The learning targets for this lesson are that you will be able to identify if a point is a solution to an inequality, and that you will be able to graph the solution to a two variable inequality. A linear inequality is an inequality with two variables related to a linear equation. An inequality with two variables related to a linear equation. So you may ask, well, wait a second, didn't we graph inequalities already when we had x is less than or equal to 5? Yes, we did. Okay, when we solved a problem that involved only x and didn't have any other variables, we were able to graph that on the number line, and in doing so, we had graphed one variable inequalities. So that was one variable inequalities. Now, we may have them in a two variable system where it's related to the x equals a number equation, the vertical line here. So you need to pay attention. If there's a system of inequalities, then that's a little bit different. But for right now, we're not looking at a system. We're looking at individual ones. So if you have one variable, you're going to do this. If you have two variables, you're going to be doing what we're about to do for graphing. A solution to a linear equality is any, or rather all, because there's usually many, and usually infinitely many, points that make the inequality true. So any or all points that make the inequality true. To test this, you don't have to solve for x or y. You're just going to plug in the points, the x-coordinate and the y-coordinate, and evaluate it to see if the inequality is true or not. So for all three of these points that I'm testing in my first example, I'm going to copy this inequality, but in place of x, put in their x-coordinate. In place of y, put their y-coordinate. So I have 5 by x is less than or equal to 10 minus 4 times y. 5 by x is less than or equal to 10 by 10 minus 4 times y. 5 by x is less than or equal to 10 minus 4 times y. Since I'm going to be doing this multiple times, I'm just going to write it out real quick so I don't have to slow down and think about it later. Now I'm just going to double check. Yes, I copied all three of those correctly. So now I put my x-coordinate in where the x was. Double check that that's where the x-coordinate was. And my y-coordinate where the y-coordinate. And my y-coordinate in for y. We're going to focus on just this one right now. 5 times negative 3 is negative 15. Less than or equal to, this is going to be negative 4 times 5, which is negative 20. And 10 minus 20 is negative 10. This inequality is false. So this point is not a solution to the inequality on the left side of your paper. For the next point, we've plugged in 4 and 1/2 for the x and y coordinates respectively. 4 times 5 is 20. Negative 4 times 1/2 is negative 2, and 10 minus 2 is 8. So this says 20 is less than or equal to 8, which is false. 20 is actually greater than or equal to 8. So since this is false, a false inequality, this point is not a solution to our inequality on the left. On our last one, 5 times 2 is 10, less than or equal to. Negative 4 times negative 5 is 20, positive 20. So 10 plus 20 is 30. This inequality is true. And when the inequality is true, then that point is a solution, is one of infinitely many. So this is a solution to the inequality. Try this for the next problem. For these 4 points, Take a moment to pause the video and try it for this. All right, so for this next one, what you should have, is 3 by x over 4 greater than 2 by y plus 1. In this case, the x is 4, the y is 1. Over here, I should again have 3 by x over 4. Is it greater than 2 by y plus 1? Here, my x is negative 8. Here, my y is 4. Down here, 3 by 4, not 3 by 4, 3 by x over 4. The x is 2. Is that greater than 2 times y plus 1? The y is 3. And 3 by x over 4, is that greater than 2 by y plus 1? The x negative 4, the y 8. Now that I have this plugged in for each of these, I'm going to see if I can simplify them and see if any of them are true. This becomes 3. On this side, we have 2 plus 1, which is also 3. 3 is not greater than 3. If it had a greater than or equal to 2 symbol, it would be fine. But this is false, so this is not a solution. This point is not a solution. When I plug this in, negative 8 over 4, negative 8 is really negative 4 times 2, or 4 times negative 2. The 4's are gone. Negative 2 times 3 is negative 6. So I'm testing to see if negative 6 is greater than what I have on this side. 2 times 4 is 8 plus 1 is 9. Again, this is not a true inequality. It's false. So this point is not a solution. For this one, I have 6/4, which reduces to 3/2, because 2 will go into 4 2 times. On this side, I have 6 plus 1, which is 7. 3/2 is not greater than 7, so this is false. This point is not a solution to the inequality. And lastly, over here, negative 4 over 4, that's negative 1. Negative 1 times 3 is negative 3. Is that greater than 2 times 8, which is 9, plus 1, which is 10? And it's not. So, since it's not greater than, this is also false. Not one of these was true. This point is not a solution to the inequality. Next, we're going to look at graphing the inequalities. I'm going to have to write it on the next page because it got cut off. Well, actually, I'll just slide it up a little bit. So I have these inequalities. That's not even the right page. All right, somehow it really got cut off. Okay, so we'll just use these graphs right here. Y is less than 2x plus 5, and we have this graph right here. So what I need to do, and you're like, well, I don't have any points to test. You don't want to test every point in here. When I go to graph an inequality, the steps that I'm going to take is I'm going to pay attention to whether it's strictly less than or whether there's equality. If it's less than or equal to or greater than equal to, I'm going to graph it like a line, graph it like a solid line to start. The first step would be to graph a solid line. Now, you can choose your method, right? This one's in slope-intercept form, so I'd probably just start at the y-intercept and follow the slope. But if I forgot to do that, I could make a table, or if it was in standard form, like one of the other problems on the next page, I believe it's letter C, then I would actually probably use X and Y intercepts to get my 2 points for the line. But the whole point is the very first step is to graph a line. Now, if it's solid bars, you're going to graph a solid line. But if it doesn't have equality, if it's strictly greater than or strictly less than, then I have to use a dotted line. I call it a dashed line, but other people call it a dotted line, to note that there isn't equality. Basically, the solid line means that every single point on that line is a solution to the line and a solution to the inequality. So by putting a dashed line, I'm saying that that line is kind of a border for the inequality, but any point that's on the line is not a solution because it's strictly greater or strictly less than. So for this one, because of the symbol, I'm going to have a dashed line. For this one, because of the equality, I'm going to have a solid line. So I'm going to follow our first steps of putting a dashed line on the first example on the left. The y-intercept is 5, so I'm going to start at 1, 2, 3, 4, 5 and put a point. And then I'm going to go, our slope is 2, so that's 2 over 1. Or if I want to go in the reverse order, negative 2 over negative 1. So I'm going to go up 2 and right 1. That only gives me 1 point, so I better do some more. This means I'm going to have to go down 2 and left 1, down 2, left 1, down 2, left 1, down 2, left 1. Keep doing this till I'm to the end of my graph that I can do it for. Because of it not having equality, I'm supposed to use a dotted or a dashed line. So through each one of those points, I put my dotted or dashed line. This means that any point on that line is not actually a solution because any point on that line makes the left and the right side of our inequality equal. And they're not supposed to be equal. The right side is supposed to be strictly greater. Now, there's some tricks that you may have learned that when you have y on one side, you can just, shade up or shade down above the line. But really, you want to understand what it is that you're doing, and there's a better way to make sure that you're consistent and that your answer is correct. Once I have the dotted line, I'm going to select a point, a test point. Test a point that is not on the line. This is step 2. Now, I can use 0, 0. It's a really handy test point. It's very easy to plug in 0, 0, but if that's on the line, then you can't test that. You'd have to pick something like this, maybe 0, 3. If the line goes through 0, 0, you maybe want to test 0, 3 or 0, negative 5, something like that, or any other point anywhere on the graph, because something on here, either these points over here or these points over here are going to make the inequality true. So I picked 0, 0 as my test point. So I'm going to plug that in. This is my y, so I plug in 0 is not less than or equal, just strictly less than my x, 2 times my x plus 5. Well, 2 times my x, that's 0. So I'm saying 0 is less than 5. This is a true inequality. And any point that makes our two-variable inequality true is a solution. So 0, 0 is a solution. It's one of infinitely many. And so that means that the points on this side are the ones that are solutions, every point on this side. So from my dashed line, I take my pencil or pen, and I come toward that point and toward all the points on that side and shade as my solution set. Let me show you, though, that the other side doesn't work. If I had instead picked negative 1, 2, 3, 4, 5, 6, 7, 8, we'll just do negative 8. If I'd picked negative 8, 0 as my test point, or any point on the side that's not shaded, I would have had 0 in for y, would have had 2 times negative 8 plus 5. That would have been negative 16 plus 5, which would have been negative 11. In that case, I would have said, oh, that inequality is false. So this side should not be shaded. So since this is not a solution, it shouldn't get shaded. Only solutions should get shaded. So step 3 is to shade the true area. Shade the true area, or the points that are true. Every point on this side is true. Every point on the other side is false for that inequality. We're going to look at one more example of this. Y is greater than or equal to negative 2/5 x minus 4. And so again, it's in slope-intercept form. I'm going to start at negative 4. And I'm going to go, again, negative 2/5 could be written as negative 2 over 5 or 2 over negative 5. So initially, I'm going to go up 2, actually down 2 and right 5. Down 2 and right 1, 2, 3, 4, 5. And then I'm going to go up 2 and left 5. 1, 2, 1, 2, 3, 4, 5. It gives me 3 points to graph for my line. Because of the inequality, I'm going to use a solid line because of the greater than or equals equal to, because of the equality, I'm going to use a solid line. So I connect those 3 points with the solid line. That means that every point that is on this line, all of them, and there are infinitely many, every single one of them will be a solution where the right side is exactly equal to the left side. It'll be a balanced equation, and it has equality, so we're good. Now, I need to test a point. I can test 0, 0 as long as 0, 0 is not on the line. If it is, then I might test 0, 8, or 0, negative 8, or some other point on the y-axis that isn't on the line. So when I plug in for y, I have y is greater than or equal to negative 2/5 x minus 4. My y-coordinate is 0, negative 2/5 times 0 minus 4. This stays 0. Negative 2/5 times 0 is 0. So now I have 0 is less than or equal to negative 4. Or sorry, greater than or equal to negative 4, which is true. This is a true inequality. Since it's a true inequality, that point 0, 0 is true, and I should shade toward that point, the true points. Had I picked a point over here, I would have gotten a false inequality, and I would have said this is the side that should not get shaded. We're going to look at letter C. If you could please go to letter C. We're going to find our inequalities for that right now. All right, so please take a moment to try letter C. You should be able to graph this. You can, if you prefer using slope-intercept form, pretend it's an equation and solve for y to get slope-intercept form, although that's not always going to work for things that are in standard form. So I would recommend using the X and Y intercepts to graph this. So use that to get your line and then decide whether you should use solid or dashed, and then test a point. All right, welcome back. So if you were doing this using the X and Y intercepts, our x-intercept is where we cover y and solve for x. So in this case, I have 3x equals negative 9. When I divide by 3 on both sides, I get x equals negative 3. So negative 3, 0 is my x-intercept. Also, for my y-intercept, if I cover up the x, I get 3y equals negative 9. I'm not worrying about the inequality right now. I am just trying to find points to plot the line part. So when I divide by 3, I get y equals negative 3 also. So this is 0, negative 3. Since those are points on my line, when I do go to test a point of the inequality to see if it should be shaded or not, I do not want to test these points because they are on the line. So I'm going to plot these. I have 0, negative 3, and I have negative 3, 0. That's enough points to get my line that will represent the line 3x plus 3y equals negative 9. Now, the question is, do I need a solid or a dashed line? Because of the equality, I need to use a solid line to connect my points. So I connect my points with a solid line showing that every single point on that line is in fact a solution because it will make the left side exactly equal to the right side, which is okay since it's less than or equal to. Now, I can pick any point that's not on the line, and once again we luck out that 0, 0 is not on the line. So I'm going to use that as a test point. Testing 0, 0. This is for letter C. So I have 3 times 0, my x-coordinate, plus 3 times 0, my y-coordinate, is less than or equal to negative 9. Well, that's 0 and that 0, 0 is less than or equal to negative 9. This is false. This inequality is false, which means that 0, 0 is not a solution to our inequality. And since it's not a solution, this side should not be shaded, which means that I'm going to go to the other side and shade the other side. And just to prove this to you, I will pick a point from the other side. I'm going to pick 0, negative 4 as my next test point. You don't have to. If you know that this side is false, then you know you're going to shade the other side. You don't have to do an additional test point. But I'm going to show you right now for 0, -4, if I were to plug that in, I'd have 3 times 0 plus 3 times -4 is less than or equal to -9. The 3 times 0 goes away because it's 0. The 3 times -4 is -12, which is less than or equal to -9. This is a true inequality and is the side that should be shaded. And so that point is included in the shaded area. Every single point on this side of our line and every single point on this line is a solution to the inequality given here. This concludes the notes for lesson 1.5. Have a great day.